In this video, I'm going to walk through the various screens for the container surface description input, and I'm going to use the dialog box that was created in another video. But as was mentioned before, there are a number of release types that you can have. The one that's really the workhorse of CHARM is the container surface description. There's also pool lagoon, a user specified after release condition, and a user specified concentration grid. As I say, the first one, the container surface description, is the workhorse, so that's the one I'm going to currently work on. And I don't know if I'll make other videos for the others, since they're sort of straightforward or at least self-explanatory more than container surface, and there's a lot of overlap. But on this basic tab, which is the same for all of the release types, you have title, you do have the release type, you select a species. If you hit the button box, you'll get a list of the chemicals that are in the database. You can select the one of interest. If you're going to have surface deposition efficiency or surface deposition of the vapor, you can put in an efficiency between 0 and 1. The default is 0, that there is no surface deposition of the vapor. So you probably need to really know what that number is. Don't just make one up assuming there's going to be surface deposition. The next area on this screen is there are up to 6 default concentrations that you can use for depicting impacts. And currently in this one I have 3. And the one I'm working with right now, by the way, is the standard CHARM release, the default one. When you just start CHARM, this is the one that comes up. The one I'm working on right now is for version 11, the complex terrain version, but there's a lot of similarities, and there's more in version 11 than there is in the flat terrain or version 9. But you can select units for the concentration impacts. And one other feature you can have, this is not in the flat terrain, but you can have a start delay. So if you have multiple releases going on, one release can start at one time, another release can start at another time. So you just put in how long since the beginning of the earliest release. In other words, how much longer or past the first release starts that then this release will start. If there's only one release going on, it's ignored. But if you've got 2 or 3 or whatever, you can actually stagger the releases. And there's an emergency response output. That is if you're using CHARM in a real-time or emergency response mode, and you can just tell it whether you want to have a plume displayed or a mechanical overpressure. It depends on what the release description is describing, determines what is in that list. But usually if you are in emergency response mode, you've got some more information anyway, so I mean you know how to fill that in for your case. But now we'll go to location, and in here you can put the actual latitude longitude of the release site. In the flat terrain version, you just put an XY on a Cartesian coordinate, and you can browse a map and or browse a grid. And I will try to browse a map using the same map that was generated for the grid, or was used. We used this map to define the grid. Actually, this map was created after I created the grid by reading in the grid into CHARM iNetMaps. But then you get a nice display of the map and the grid, and you just double click on an area or a point, and that then fills in the lat long, and voila, that gets rid of that map. One of the options here for complex terrain version, you can actually create a table of a track, x, y, or lat long and height as a function of time or a function of speed, where the track goes. So it could be something like an aircraft, or it could be a rocket launch, or it could be even a truck on a road. And you can just specify where it is as a matter of time. And when Charm does the simulation, it goes through the track, finds out where it is at a given time when an emission is occurring, and then does that emission. Next tab is container, and there's 3 container types: vertical, horizontal, and spherical. Vertical and horizontal, you can think of those just as cylinders. It's either on its side for a horizontal tank, or vertical, upstanding cylinder, and spherical tank. Depending on which one of those you select, you get various options here for the length, height, length, diameter. For instance, if you're in spherical, you will only be given the chance of putting in the diameter. But I'm going to stay with horizontal. There's something called mitigation time, and that means when the release is going on, this mitigation time specifies when the release stops. Somebody comes in or something comes in, shuts the hole down, or does something to stop the release into the atmosphere. And that's what the mitigation time is. For the container, you can have an amount of liquid. You can either give it an amount or give it specify a depth. And if you give too much of an amount or too big of a depth, then one of the values up here, like if you give a depth of 20 feet, then the diameter of a horizontal tank would be changed to 20 feet. Just to make sure that everything's self-consistent. Going to storage, these are the temperature and pressure that are the storage conditions for the container. And you can actually have Charm calculate one or the other. Can't quite calculate both, but you can assume ambient, if you just have an outside container that's kept at atmospheric pressure, or rather at atmospheric temperature, then that is the default case. And then Charm will calculate what the pressure is. And what it does is goes down to the meteorological data and finds out what that temperature is, and then calculates the corresponding pressure for that temperature. Or if you have a given pressure, then you can calculate the temperature. Or if you know both, just give them straight away. Tab for hole is how the material gets out of containment and into the atmosphere. So it's how high above the ground you are where the material enters the atmosphere. And there's a height above the container bottom. That sort of determines how much material, how much liquid, if there is liquid, can get out. If you have liquid in the container, the liquid will pour out of the container only until there's as much liquid in the container left that there is the height above the container bottom for that hole. In other words, if the hole is 3 feet up, once there's 3 feet deep liquid in the container, no more liquid will go out that hole. If it's still pressurized, then the vapor will depressurize through the hole, but the liquid release will stop. You can also specify a diameter or a release duration, and if you specify a release duration, then CHARM will calculate the diameter in order to get all the liquid out of the container down to that hole height above container bottom. If you give diameter, it just takes that straight away. On the other hand, diameter can also be specified as an area, and that's designated by the units being squared. And finally, well, not finally on this one, is a horizontal direction that the release is pointing. If, in this case, the vertical angle is 0 down at the bottom here, that means it's going straight out into the air parallel to the ground. And so then the horizontal direction can become important if it's facing always in a given direction. When the wind changes, then it will be more mixed due to the wind than not. So the default is that it's just facing to go along with the wind. As I say, vertical angle, it can be 90 degrees is straight up, minus 90 degrees, or minus 90 is straight down. Particles, I'm going to skip over that other than to say that there is a particle, you can define particle size distributions in CHARM-Ed, the CHARM editor, and save as many as you want out there, but then you can read that size distribution in, and the emission rate is prorated on that, onto that size distribution, depending on what your mass rate or particle mass fraction is of the release. Should come on a couple more tabs down the line here. For container surface description, you have a pool or a potential pool that may form. If liquid does come out of the container, it can fall onto the ground and then pool. And you can tell it the height above ground of the pool, defaults to being on the ground, the maximum diameter that that pool can form. For instance, if you're in a bermed area, a tank in a bermed area, then the pool can never be larger than that. Hopefully, the berm height is strong enough or high enough to contain the release. Next is mitigation time, and that's similar for the release from the container itself, but this is when the pool gets mitigated. And the solar radiation evaporation efficiency, if there's solar radiation present, which it was defined in the meteorological tabs, that energy can be used to actually evaporate the pool that forms. And it defaults to 1 just because that was what was in the implicit in the earliest versions of CHARM. But from my experience so far, it probably should be closer to 10% or 0.1 rather. Surface, this is a number of surfaces are already input, asphalt, concrete. You can specify water, but besides that, you can define your own. The very first one in the list is user-specified or user-defined surface. So if you start entering numbers in here, it'll automatically switch over to user-defined. And the water fraction is, how much of that surface is water. So if you're, let's say, concrete, but if it had been raining, the 0.15 may be okay. If it's been completely dried out, then 0 is okay. These other values are defined somewhat or discussed a little bit in the help, so you can always go into help and find those. Now you may have between the container and the hole, there may be a pipe, because the pipe may actually be, the release comes out of the end of the pipe. So in here you can specify the total length of the pipe, its diameter, and a roughness factor. Those are also mentioned or discussed somewhat in the help. and there are even pictures of the globe valves and gate valves, so you can determine, knowing what your pipe is, what the proper entries are. Next is the droplet mass fraction. As I said, if you have a particle size distribution, the emission rate is placed on from the emission rate. This droplet mass fraction is used to calculate how much of the mass is droplet, and then it will be specified onto that particle size distribution, or if there is no particle size distribution, CHARM will do some internal calculations just from the mass or the properties of the liquid, of what the droplet distribution is, or it'll probably end up being monodisperse, single size. Levy burn efficiency, well, generally you leave that calculated by CHARM, but that's also mentioned if you need more info in the help. And you can have that the container is warmed during a fire, so it may vent. And if that's clicked, then it will vent, and if it's not. And last is definitely only in complex terrain version. These are radionuclides that can be released in the mission. So it will assume, using your mass fraction, how much of the material that's being emitted in your release description is radionuclide, and then CHARM will make available radionuclide or radiation impact screens generated once you do have a plume. And those, in fact, if you have droplets, they can deposit on the ground, so you can have, as well as cloud shine, you can have ground shine of radiation. So those are the basic inputs for the container surface description. I think I'll make another video goes through the meteorological, but I don't know, well, I'll just leave it at that. Once you've defined things, I'll say, okay, then be sure that you save it. So do a save as under the file for the release description. I've already got one there, but make sure you save it. And that is it for this one.